Hello, I'm Cameron Bishop, and for my final presentation, I'm going to be talking about gases. So first off, what is a gas? Well, a gas is a state of matter. It expands freely, the particles are very spread out, and it has no stated shape or volume. Now, with this being said, they can make gases very hard to find. Well, first thing we're going to jump into is how to find gases. Well, to first find them, you want to find the pressure of them. That's the main part. Find the pressure of an air, of a gas, of something of that matter. So, you can use this by solving the ATM. Now, the ATM is the most often conversion you see, okay? We'll go ahead and just jump into an example problem to best explain that. So, the example problem is the pressure of a gas is 725 torr. What is the pressure of the gas in ATM? So basically, you're trying to find the pressure of the gas, and the unit for that is ATM. So, 1 ATM is automatically 760 torr. That's our given. That's what we already know. And that's where you start this problem off with. So, as you see, the rest of the work will be on the paper. So, to set up this problem, we're going to already start with what is given over 1. We always put what is given over 1. Okay, so in the given problem, we have 725 torr. So we're going to put 725 over 1. Okay, that's our first thing. Now, we're going to multiply that to the what we already know. So we know that 1 ATM is equal to 760 torr. So we have 1 ATM over 760 torr. The reason we put torr on the bottom is because we have torr on the top over here. We want them to cancel out. So we have 1 on the top, 1 on the bottom. So what we're going to do is we're going to multiply that together, and we're going to divide. So basically, it's going to be 725 torr divided by 760 torr, which is 0.9539 ATM. Okay? That's our final answer. It's a simple early problem, but you get the gist for how to find your ATM. Now, Boyle and Charles' law. Now, these are two men, very interesting men that actually had different results with the way they found things. Boyle found that the volume and pressure vary inversely, whereas Charles, they are more direct. They're more of a direct. So basically meaning Boyle's was P1 times V1 equals P2 times V2. Okay. Now, Boyle's law states that the product of the initial pressure and the volume are equal to the product of the final pressure and final volume. So that's back to our P1 times V1 equals P2 times V2. That's more solvable. So then we come to our Charles' law. Now, Charles was a little bit different when he was stating this. So Charles stated that the volume of the given gas amount is held constant pressure and is directly proportional to the Kelvin temperature. As the volume goes up, the temperature also goes up, and vice versa. They're more together. It's a direct relationship. Now, I don't know if you can see this, but V1 over T1 equals V2 over T2. Now, that's more, he involves the temperature. Now, some gas law problems. Gas law problems, there are tons of them that you can do. Now, the main one I wanted to jump into was the ideal, because the ideal is the combination of all the different types into one. It's often the most difficult, and I found very hard to find. So I put an easier problem on here, just kind of get us started and set our main standard. So here we go. The idea, a gas law, is a combination of all three problems. That's what I stated. Now, Dmitry Mendeleev, created this. So all these different chemistry brainiacs put all these different laws in and everything. And Dmitry just combined them all together. Put them all together. I am a very smart man, if I do say so. Now, So here's our first example problem. If I initially have 4.0 liters of a gas at a pressure of 1.1 atm, there's our atm, that we actually found in the recent problem. So you can see how these can kind of connect. You put them together, you find the atm connected into here. But 1.1 atm, what will the volume be if I increase the pressure of 3.4 atm? Okay, you're probably wondering, where do I start? Like, well, it's very simple, actually. Well, it's not simple, but for this problem, it's simple because it's an easier problem. We're going to start with, so you're going to set up your first two. You're going to have them multiply together. So that's just set us up. So you're going to have 1.1 atm times your 4.0 liters. That's on the left side. Now, on the opposite side, you want to have the final times the other thing, but times what you're raising it by. So what you're raising it by is 3.4 atm. Now, we don't have our final, so we're just going to put it as XL, okay? The amount of liters, okay? Now, basically, all you're going to do is solve for each one. All you're doing is solving. So when you do all that work and you solve it out, you're basically going to get X equals to 1.29 and then L equals to 1.3, which is actually 1.3 liters. That's our first problem. It's more of a simple one. Now, how to interpret graphs for gas laws. Okay, here we go. So how to interpret graphs? Well, these are very interesting. Now, this one right here, I don't know if you can see very well, it's kind of hard to read, but it says volume going up and temperature going across. That's our more direct, what's the word I'm looking for? They have a more direct relationship, versus this one is where they vary very inversely. Okay, you can see how they go. So it's here, when the volume goes up, the temperature goes up as well. It's a very direct relationship, where this one, it's inversely. So it's actually the opposite. You could put in numbers and stuff, and there's more you can go into, but that's just like the main deal, the main setting up of how you would interpret and read one of these graphs, and the main problems. That is all I have for this presentation, so thank you very much.